Welcome to class, ladies and gentlemen. Mr. Eicher here, but not really here. But I am here to teach you a lesson on nth roots. It sounded really dramatic. I'm not sure why. So, nth roots. This first question that you are going to do as a warm-up, but we'll talk through it. Write each number in each expression as a square of a number or a square of an expression. So you want to write this so that, for instance, 25, so we write it as a square of a number, that would be 5 squared. Gasp. I know there are many questions about this, but we might have to move on. 0.09. Oh, okay. Now it's a little more interesting. We want to write that as a square of a number, parentheses squared. I believe it's going to be 0.3. We're going to need a 3 to get a 9 out of it. 3 squared is 9. So 0.3 squared is 9. Now the next one, let's change the color up on this one. The answer here, something squared. 2 squared is 4, that would be the numerator, and then 49 squared, 49 squared, that would be way too big. 7 squared would be 49. And then algebra comes in, math. X to the 10th as a square. Well, we would have, put a little square there. Something squared is x to the 10th. So that would be x to the 5th. Get rid of that. What are you doing there? Number 4, or number 5, something squared is x to the 4th y squared. Well, x squared, if it's squared, it would be x to the 4th. And y by itself squared would be y squared. So this is x squared y, that quantity squared. And then the last one, number 6, writing this as and this expression as a quantity squared. What squared is 169? That would be 13 times 13. And what squared would give me x to the 6th? That would be x to the 3rd. And that would be a y to the 6th. If you can read that 6 in there, it's kind of small. So why are we doing these? Why are we warming up with these? The idea of today's lesson is that we're going to be taking square roots of things. And to be able to do that, it's going to be really helpful for you if you recognize how to convert this y to the 12th into a y to the 6th to the 2nd, a y to the 6th squared. Because if you think about it, if you take the square root of 169, you would get 13. If you took the square root of x to the 6th, if I can write an x on this, x to the 6th, if you do a square root of that, you would get x to the 3rd. If you do a square root of y to the 12th, you would get, highlighter, y to the 6th. So this idea of breaking an expression or a number down into like a square of a number or a square of the expression. Basically what we're doing is doing a square root when we do that. So roots and radical expressions. We've talked about square roots, but there are other roots, obviously. You have 5 squared, that would be 25. So the square root of 25 is 5. Or 5 cubed is 125. So we would say the cubed root put a little 3 right here, the cubed root of 125 gets us back to where we started. That would be a 5. They're inverse operations to relate it to what we've been talking about. If we cube something, the inverse operation of that is cube rooting that something, and it gets us back to where we started. Or we have 5 to the 4th, which is 625. Divide this a little bit. The inverse of that would be doing a 4th root of 625. 4th root of 625. And that gets us back to 5. So the definition of a nth root, is for any real numbers a and b and any positive integer n, so you can't have like a negative 1th root or a negative 2th root. Negative 2th root is kind of fun to say, but we don't have those. If a to the n equals b, then a is the nth root of b. So like we were doing before, if we have 5 to the 4th equals 625, a, which is 5, a is the 4th root of 625. Or in other words, five is the 4th root of 625. So since 2 to the 4th is 16 and negative 2 to the 4th 16 is equal to 16, both 2 and negative 2 are 4th roots of 16. It's kind of a positive and negative issue. However, since negative 5 is the only real number whose cube is negative 125, then negative 5 is the only real cubed root of negative 125. We can kind of generalize this in this table below. Let's say we have a positive number, and we want to know the number of real nth roots when n is even. So let's say we have that 16. 16 is a positive number, 16, positive 16. And let's say our n is an even number like 4, so the 4th root of 16. This would equal something like x or something. So really what we're trying to solve is x to the 4th equals 16. So what numbers to the 4th is 16? Well, we get two answers right there. We get 2 to the 4th is 16 and negative 2 to the 4th is 16. So in this part of the table, how many real nth roots are there? Well, there's 2 total real nth roots, being this negative 2 and this positive 2. There are 2 of them, a positive and a negative. Now let's go across the table. Let's take a positive number, like 27, we'll say. And now, if our index, our n, the n is called the index, if our n is odd, we don't have that issue of getting 2, like a positive and a negative. We would only get one real answer. And that's what we had up here in this line. Since negative 5 is the only real number whose cube is negative 125, negative 5 is the only real cube root of negative 125. So in this table, if you have an odd index, you only ever have one real root, regardless if the number is negative, positive, or 0. For the next one, what if the number is negative, That would be just like saying, what if we do a square root of a negative number, like -4? How many real nth roots are there? Well, there won't be any because the square root of -4 is I, the imaginary unit. So this has no solutions. And then if the number is 0, I don't know if you want to do an 8th root. 8 is an even number. The 8th root of 0 is 0. There's no positive 0, there's no negative 0, there's just 0. So you get 1 real root. So we could kind of generalize if I were to, I always like using the circle option, so let me use the circle option right here. So if we could generalize the odd, anytime you have an odd index, it's pretty happy. You get one answer. There's none of this, oh, I forgot one of the answers. But when you have an even root, you have to be careful because there may be no solutions, or there may be 2 solutions, or there could be 1 solution. So we have to really be careful and think about what's going on. So let's look at a couple basic numbers. The directions say to find all the real roots. So first we have cubed roots. So that would be multiplying the same factor 3 times. So what times what times what is 0.008. I believe that's 0.2. That would be 0.2 cubed is 0.008. So the cubed root of 0.008 is 0.2. Now we have a negative number next, but the cubed root of that would just simply be -10. -10 cubed is -1000. So the cubed root is -10. And then the last one for the 27, the cubed root would be 1/3. And you don't have to worry about multiple answers. However, on number 8, you would have to worry about multiple answers because you have 4th roots. So the 4th root of 1 is positive and -1. That just is because if you had -1 to the 4th, you would get 1. With the decimal here, we would have, oh, it's a negative, so that makes it easy. It's a negative number, an even index. So a 4th root of a negative number is undefined. It doesn't have a real number answer. So no solution for this, no real number solution. It would be an imaginary answer, but no real number solution. And then this last one, you'd have 4/9. Oh, not 4/9. Erase that. We're doing the 4th root of 16/81. So the 4th root of 16 is 2, and the 4th root of 81 is 3. And you could have a positive or a negative. Why is that? Well, you could raise this to the 4th, and positive 2/3 to the 4th is 16/81, and negative 2/3 to the 4th is also 16/81. How about pause this video and complete number 9 and number 10? Here are the answers to number 9 and number 10. Notice that on number 10, this right there is no solution. A square root of a -1 gives you no real number solution. It does give you an imaginary number solution. A couple vocab terms. I mentioned index before. The index is the n right there. N is the index. The radical sign is the radical sign. And then the radicand is the thing under the radical, what you're square rooting or third rooting or fourth rooting. When there is more than one real root, the positive root is called the principal root, the main root. So if it's just written like this, then you can assume that you're talking about the principal root, principal square root of 16, which is positive 4. You'd have to have the negative out in front if you want to refer to the negative, and then you could also have the plus or minus if you want to refer to both. So let's simplify a few of these on 11 through 14. we want plus or minus the square root of 1/16. Well, the square root of 1 is 1, the square root of 16 is 4, and it's plus or minus that answer. So that's our answer, plus or minus 1/4. For number 12, we can simplify. Negative 7 squared is 49, and the square root of 49, this is the principal square root, so it's understood that we're only talking about the positive answer, so our answer would just be positive 7 is the square root. Number 13, the fourth root of 16, so that's what to the fourth is 16, and that would be a 2, the fourth root of 16. And lastly, the cubed root of negative 27 is negative 3. So those are all of our answers. If you would take a calculator out, want to make sure you know how to evaluate different nth roots on your calculator. So you might want to pause this video as everyone is getting their calculator out. There are many calculators in the world, so I won't try to explain how to use every calculator. Your responsibility to figure out how to use your calculator. If you're borrowing one of my fancy-dancy graphing calculators, you'd hit the Math button and be looking for these different buttons. The square root of 129 shouldn't be too difficult. We can estimate that to be, what, about a little bigger than 11. But I will use the desmos.com/scientific for the scientific calculator. The square root of 129, you can do that on your calculator, 129. Enter. Oh, there it is. Your answers show up on this side, arrow. Ah, 11.358. Be careful that you round correctly. It said round to the nearest thousandth, so that would be this place where the 7 is. But the 8 to the right of that will round the 7 up to an 8. So the answer you should put is 11.358. 11.358. Now, how do we do one like number 16 where you have an index of 3? We would call this the cubed root, or the third root of 59. So that's what times what times what is 59. So let's see, if it's 5 times 5 times 5, that's 125, that's too big. 4 times 4 times 4 is 64. Oh, that's pretty close. So the answer should be close, a little less than 4. But on your calculator, the cubed root, you'd be looking for an option that looks like this button right in the middle here, right below the A to the B. And notice my cursor is blinking. Some calculators have that, others don't. But we want the third root, put a little 3 up there, of 59, and that answer is a little less than 4. Rounded correctly, that would be 3.893. The next answer, number 17, the sixth root of 4123. I'm not going to try to mentally guess that. Sixth root of 4123. Clear all of those. Have our xth root, or nth root. The sixth root of 4123. So the answer is 4.004. Rounded correctly, yep, that would be 4.004. And then lastly, we have the sixth root of 723 to the third. See if we could type that correctly in here. The sixth root of 723, is that what it said? Yeah, 723 to the third. Do I have parentheses here? Yep. Uh-oh, that's the wrong place for the parentheses. Parentheses. 723 raised to the third. And the answer you should get rounded to the correct decimal place would be 26.889. That would be the sixth root of 723 to the third. So make sure you know how to use your calculator to evaluate different roots. The last part of the video, the main part of the video, the main part of your homework, will be simplifying radicals, simplifying variables under radicals. So to explain this, since x to the 8th is the same as x to the 4th squared, those are equivalent, we would say the square root of x to the 8th is x to the 4th. Why is that? Well, if we wrote x to the 4th like we were doing in the warm-up, writing it as a square, we would have x to the 4th squared under a radical, and the squared here and the radical are inverse operations, so they are not there anymore, and you get an x to the 4th, and a little guy with a nice head of hair. Now the next one is x to the 6th equals x to the 3rd squared. So we would say the answer to the square root of x to the 6th is x cubed. And then since x to the 12th is x to the 3rd to the 4th, notice we have a different 4 instead of a 2 there, we would say the 4th root of x to the 12th is x to the 3rd. Now we can generalize, it's a little pattern. The index here was a 2, the 2th root, the square root. If you take your exponent and divide 8 divided by 2, you would get the new exponent. Or this was a index of 2. If you take your exponent and divide by that 2, 6 divided by 2, you get the new exponent. If you take 12 divided by 4, 12 divided by 4, you get the exponent that we're looking for. So just little tricks of the trade, how these things work out. Probably the hardest part for students to get a handle on is this important caution at the end of this little box here. So the caution says this: when you find the nth root of an even power, we were just doing that, all these are even. When you find an nth root of an even power and the result is an odd power, okay, we got that right over here, these are odd powers, you must take the absolute value of the result to ensure that the answer is non-negative. Wow. So, how does that change these? You don't have to erase your answers, I'm just going to get rid of some of those. This was x to the 4th, x to the 3rd, x to the 3rd. What this important caution is saying is that if you have a 4th root here, and you've taken a 4th root, and you get an odd power, you need absolute value bars around that odd power. So these two answers would need absolute value bars, where this one up here would not need absolute value bars. He's sad because he doesn't get absolute value bars. Why is that? Well, if we plugged a negative into here, a negative number, like say like negative 2 to the 12th, and then did a 4th root of that, we would get a positive answer because negative 2 to the 12th is going to be positive and the 4th root of a positive number is all good. But if we plug that same negative 2 here, negative 2 cubed, they should give equivalent answers, but this one gives negative 8, and I guess this one, if we did that on our calculator, would give positive 8. This is a problem. Is the answer positive 8 or is the answer negative 8? Well, it was a principal square root. It was a positive square root of, or sorry, the 4th root, the positive 4th root of x to the 12th. So when we put the absolute value bars in here and here, it's ensuring that, hey, we want the absolute value of this answer, so it'll match this answer over here, 8. So the absolute value of negative 8 is positive 8, and then we're very happy because they match. Now let me explain that again, because that's a lot to take in. I know it can be a lot. So I have a couple other examples, then we'll do a lot of practice. Hopefully you get your brain wrapped around this. Why are the absolute value bars needed? Well, let's say we evaluated this first one and said, oh, well, that's the same as the square root of 25. Negative 5 squared is 25. And the square root of 25 is 5. However, since the squared and the square root are inverses. They cancel each other, and we're left with a very suspicious -5. So which one is it? 5 or -5? I'm not really sure. That seems strange. Well, what we do is, to make sure we get the correct answer, we say, oh, I had an even index and I got an odd power. That was -1 to the first. So I need absolute value bars around this so I can get the correct answer of +5. To explain it again, this -2 to the 6th. Let's see, 2 times 2 is 4, 2 times 2 is 4, 2 times 2, so 4 and 4. So what is that? 64. So this would be the square root of 64. That should equal 8. However, we could do a square root of something to the 6th, and that would give us -2. Let's see, 6 divided by 2, 6 divided by the index of 2 would be a 3. -2 to the 3rd. -2 to the 3rd is -8, and we got ourselves a problem because -8 isn't the same, not equal to +8. So how do we fix that? We use absolute value bars. The absolute value of -8, that equals 8. One more. This one doesn't have numbers, but we can evaluate this. We have the square root, and we have a 6. So we can do the 6 divided by our index, and that would be a 3. So we'd have x plus 1, that quantity, to the 3rd. This one's harder to tell, and harder to be reminded, like, oh yeah, I better have absolute value bars. But this, because we have an odd index here, we need absolute value bars around that quantity. Okay, so let's try our hands at several examples. We have, first off, drum roll please, directions, simplify. No problem, we'll simplify it for you. Number 19. Maybe we'll try to zoom in a little bit. Square root of 49 m to the 6th. That would be the square root of 49 is 7. The square root of m to the 6th would be m to the 3rd. And we have to be careful. We got an odd answer here, odd exponent, and we had an even index. So this quantity should be positive, but this quantity potentially could be negative. M to the 3rd could be negative, depending what m is. So we need absolute value bars. So this is our answer, the absolute value of 7m to the 3rd. Let's look at number 20. Number 20, we would have a square root of something to the 4th. So we can write that as 5g's in parentheses, 5 grand, 5g's, 5g to the 2nd. To the 2nd because we had a square root of something to the 4th, so 4 divided by 2 is the new exponent 2. So we would get 25g squared. Do we need absolute value bars? Is it possible for this quantity to be negative? I hope you would say no. G squared is a positive, and 25 itself is positive, so we do not need absolute value bars. You should not include absolute value bars. Don't go around putting absolute value bars around everything. If you don't need them, don't use them. 25g squared. Let's look at 22 since it's on the screen. 22, we would have the 4th root of z to the 8th. We'd have 8 is our exponent, and we divide by our index, and that would be 2, z squared. Do we need absolute value bars? Can z squared potentially be a negative number, negative value? No, That's our final answer. How about you pause this video and try 25, 26, and 23. And once you get your answers, compare them with your neighbor to see if you agree and you're both understanding everything. And my last caution, remember to use absolute value bars when appropriate. I don't want you just putting absolute value bars around everything. So pause this video and try those out. All right, we are back. Let's look at 23. The square root of 169 is 13. The square root of x to the 8th is x to the 4th. And the square root of y to the 4th is y squared. Do we need absolute value bars? Is it possible for this expression to equal a negative number? I hope you said no, you do not need absolute value bars. That is our final answer. The expression over here, the squared and the square root give you an exponent of 1, so you're left with 4x minus 1. Is it possible that this quantity equals a negative number? I hope you said yes. It could, depending on what x and y is. So you need absolute value bars around this quantity. That is our answer. And then the next one here, we have a cubed root. Hope you didn't miss that. You have a cubed root right here, an index of 3. So the cubed root of 8 is 2. The cubed root of a cubed is a. And the cubed root of b cubed is b. Now, do you need absolute value bars here? Well, because the index is odd, we can do a cubed root of a negative number. That's fine. You can get a negative number. So this quantity doesn't have to be positive. It can be negative, and we're all fine. So you never need, did I say never? Did you, you never need absolute value bars when you have an odd root. It's only when you do square roots or even roots that you could get like an imaginary number answer. So with odd roots, you never need absolute value bars. Never. I think there are 2 more that we can check out on this page just to make sure you are getting this idea. If you'd like to pause the video, try 21 and 24. Again, be careful if you're using absolute value bars or not. Here we go. Here are the answers. Other than do you need absolute value bars? This 21's pretty good. Can this quantity, it is an even index, so we need to ask, is this quantity, could it be negative? Yes, it could. Where do you need the absolute value bars? You don't need the absolute value bars around the x squared. You just need the absolute value bars around the y cubed, because that's the part that could potentially be negative. So very specifically here, the absolute value bars would go around the y cubed. Similarly, you'd have absolute value bars around the a plus 1 cubed, because that could be negative, and we started with an even index. Let's end this lesson and class after looking at a little application about using some properties of exponents. I just need to switch the shape of the screen. Alright, so the question below, use properties of exponents in estimation, no calculators. Ooh, challenge accepted. We'll see what we can do. The velocity v required for an object to escape the gravity of a planet or other body, like a moon, is given by the formula v equals the square root of 2gmr, where m is the mass of the body, r is the radius of the body, and g is Newton's gravitational constant. Use that a lot in physics, I would guess. Use m equals that, r equals that, and g equals that to find the escape velocity for Earth. That would probably be pretty important if you're trying to escape Earth. The zombies have come and you have to inhabit a new planet. These things happen. So we have trying to find the escape velocity, the square root of 2 times g. G is 6.67 times 10 to the negative 11 times m. The mass is 5.98 times 10 to the 24 all over r, which is 6.37 times 10 to the 6th. Now if you're going to let me estimate, let's do some estimation here. Probably going to need a little more space. Square root. Let's estimate. Let's see. We'll do 2 times 6.67. That would be 13.2-ish, so 13.2. We're going to do 13.2, let's just call it 13. We're estimating, right? 13. We're going to multiply that 13 by this number, and we'll call that 6. 13 times 6. We also have this 10 to the negative 11. We'll multiply that by 10 to the 24th. That would be times 10. Add the exponents and you get 10 to the 13th. If you hear that background noise, that is my puppy playing with a bone. And then the denominator, we have 6.37. That sure would be nice if that was 6. Let's just round down to 6. Times 10 to the 6th. The 6's will divide out. The 10 to the 13th and 10 to the 6th will give us 10 to the 7th. So we have 13 times 10 to the 7th. Almost there, just need a little bit more space. 13 times 10 to the 7th could be written as 1.3 times 10 to the 8th. Moving the decimal place, putting it in proper scientific notation. The square root of that. Well, the square root of this guy right here, square root of 10 to the 8th would be 10 to the 4th. So we have the square root of, oh man, I need a lot more space. What can I get? Square root of new chalkboard? Green chalkboard? Whiteboard. Whiteboard. Okay, I can write it up here now. Square root of 1.3 and then times 10 to the 4th, since we did a square root of this 10 to the 8th. Square root of 1.3 is, let's see, if it was the square root of 16, it would be a 4, so a little less than 4. What is it? Maybe 0.35? Would that be right? Maybe not. Well, if we're estimating, let's call it the square root of 1.6, and then I don't need a calculator. That would be 0.4 times 10 to the 4th. In proper scientific notation, that would be 4 times 10 to the 3rd. Or the escape velocity would be 4 with 3 zeros after it. And that is a lot of writing on the board. I'm kind of interested in what the units are. So how do I go back to where my paper is? 4,000. And it looks like the units would be velocity. I'm not really sure what the units are. Oh. Well, it's a velocity, so I'm guessing it's meters per second. So I guess our answer is 4,000 meters per second. It would be interesting to know how much that is in miles per hour, but I'm guessing in the end you better be going fast. Have a wonderful lesson. Thank you for your attention.